Welcome back to the Combo Classroom for a nighttime stream with your teacher, Demotro. Good to have all of you back. The live streams have been a little more spread out on this channel, but to make sure that all of you have been up to date with the combo going ons, I have been dropping a few new shorts on this channel, so you can always check out the shorts tab on this channel if you want to see the 3 so far that I have put out. And more importantly, there is also, well, first let me pull this up because it always glitches out when I pull it open in advance. So hopefully this time it actually shows up correctly. And more importantly, perhaps, is that I put out just about a day ago on my Combo Class channel a new mathematical episode about proving numbers are irrational. There will also be a follow-up bonus video about that on this channel before long. I'm going to get back to making bonus videos, and perhaps the first, or one of the first, will be a follow-up to some questions that some comments had here that I figured could be fun to include. I can't always include all of the fun facts in each episode, otherwise they would each be many, many hours. Now, today, what we're going to do in the background while we are chatting is going to be related to creating some graphs, like I like to fiddle around with sometimes. And you can leave any comments or thoughts in the chat, because I will try to respond to those as well. But here we can see pulling open our good old Desmos, and today we're going to be experimenting with some graphs as usual, creating some strange shapes that we have never seen before, some of which maybe no human has tested the exact combination of, and not necessarily analyzing exactly what's happening in the graph, not worrying too much about, oh whoa, this is changing things. Not worrying too much about explaining why the graphs have what shape they do, more so trying to be artists with the math and trying to see what strange shapes and worlds we can conjure. And today we're going to be using a particular type of one that we haven't used quite as much, which we've had a lot of luck using trig functions, like if we use signs of things like x squared there. Already looks pretty crazy. Sine of x squared equaling y is what they assume with the blank there. What if we say, though, that we're adding in y squared over there, and we're making it equal some value? Well, now we get really crazy. This one's one of my favorites. And they get even crazier when we make them into inequalities, because then we color in much of the realm. Now we're seeing when it's more or less than whatever I have the slider set to. But today what we're going to do for a little variation on that are some hyperbolic trig functions, which will have slightly different behavior. In this case, a bit more boring. When we did the hyperbolic sign replacing the signs in that last one, we have this strange thing that looks like a circle growing and then becomes more and more square. We can guess that it would probably continue becoming more square as we cranked this up. Now, for those who have not encountered this much yet, and I guess I should put myself here, but will make me small. For those who haven't encountered what these are, well, although, like I said, we're not going to deeply be explaining why these are making this today, we might as well take a quick look or reminder or new knowledge for some of what these are. Now, when you do trig functions, they're typically based around calculations on a circle of different triangles, essentially, that are forming between the points of a circle. Triangles, in a way, just because any distance on a graph ends up being a triangle. But the circle is what you build the typical trig functions around, and you can also build them around a different type of shape, the hyperbola. Hyperbolas are more like this, where you have arcs stretching on opposite sides of each other, and if you go far enough, you get toward this asymptote. And what we're going to see here, if you did look at why the numbers are making these shapes, you're looking at kind of triangles formed within the hyperbolas as opposed to circles. Now, going here to see how they look, first let's just see what they all look like. So we're just going to make a really simple inequality for each here. We're going to say y is greater than or equal to each of the 6 main hyperbolic trig functions, which we have our version of sine. And let's actually make this side more. There. So we have our version of sine, our version of cosine, our version of tangent, our version of secant, our version of cosecant, that one's neat, and our version of cotangent. We can see some look kind of similar to each other, but they are creating these interesting variations. Now, what happens when we start doing more interesting things with these? Well, what happens, for example, if I take the sum of one of them for x, one of them for y, and I make that, we'll say, greater than or equal to some value. Well, here we can now change our slider and go and sort of see, now that we have 2 variables on one side and we can have this third variable a changing, we can mutate them a bit. And we'll get different effects from different combinations of them. And this is just one of the simplest ways we could apply it, adding 2 different ones of them together. So what if we, for example, experiment with throwing in some exponents? Well, now this one bends around that way. And what if we put it on both of them? And now I'm going to look at our chat and just chat in general for a moment while I replace these with some other combinations, just as a very simple beginning here. Thank you to everyone who is joining me here. Somebody asked what ungodly hour it is for me, and it's actually not that late. It's 9:40 p.m. here. I'm in California, and so it's not super late here. We will probably only be streaming for not a super long one, somewhere from half an hour to an hour probably. But we get enough time here. The darkness just recently hit, essentially. And we can hear our good old train in the background, although the train is not always my friend, because I like the noise of it in a certain way, but when I'm trying to film, sometimes that train goes for a really long time. And I'll be like, Carlo, how many times do they have to honk that horn? I know they don't want any pedestrians walking out there in front of the train tracks, but you'd have to be pretty dumb if you missed the first 15 honks of the horn. And at some point, we got to be like natural selection after the 20th honk of the horn or something. So when I'm filming, the horn's a little more difficult. But anyway, fiddling around with some more combinations we can do here. What we're going to try here is adding some combinations within here. And we'll add the exponents back later. First, let's say one of them adds an x and a y, and one of them multiplies an x and a y. Ooh, now we're getting these different shapes. This one, this one we can even make an island. I really like when we can get an island like that, because then when we mutate the formula, sometimes we get cool shaped islands, as opposed to just the whole thing looking polluted. Now, there's a little island. I wonder if we can mess with that island a little bit. What happens if I multiply one of these by the same a, but it's inside here? Oh, that just stretched the island a little. What if I had added the a? Oh, it connected the island. Another comment asked if I'm in LA. I'm not. I've been to LA a number of times because I do have family there. But I live in the Bay Area of California. So here, what if we try a similar thing, changing our islands? Look at all these different islands we're able to create. Now, they're not too mutated, so if we want to go crazier, because it's not having much trouble yet, at some point it might start having a lot of trouble, whether it's that it has trouble displaying the picture correctly, or that it goes really slow and it like acts glitchy. If that happens, we have to slow our roll, but for now, we can go even a little crazier by layering these things. Look what happened when I threw another normal trig function in there. Look at all these stripes and these like anti-island, like peninsula thingies. So, now I guess we're in hyperbolic trig day, so, it's less interesting when I did that. Maybe we need to do a combo. So, combos are important, so maybe we need some of them to be the hyperbolic trig and some of them to be regular type. Now, if that went that crazy, what will happen if we add one into here? Whoa! Now, that is pretty crazy. And if we want to make a whole series of islands, we can flip this inequality. And look at all those islands we've made, with like sandbars between them. This reminds me of some David Attenborough nature videos I was watching the other day. That's like my favorite genre, is seeing the type of really cool nature show where they like go in the jungle or deep sea, and it's just like the craziest animals and plants that nobody hundreds of years ago even was able to experience, at least for the deep sea ones. And the jungle ones, some people know those animals and plants, but I hadn't seen them, So someday we'll take more field trips further and further to, maybe we'll go deep sea. Although I'd be pretty scared to be in a submarine and go that deep, so we'll see. Now, somebody asked what a hyperbola is, and I briefly showed the thing here. I didn't fully show it, but an example of a hyperbola is these red curves on this. The red ones as a pair are a hyperbola, and as I change facts about the hyperbola, they'll kind of stretch a bit. So it's sort of like an anti-circle in a certain way, but it's not necessarily the only anti-circle. As we've explored before, there's many ways to take an opposite of a concept. So there's other ways to make an anti-circle, but this is one of them. Now, back to our graphs here. I like these islands, so what I want to do is stretch them a little. So to stretch them, what I'm going to do, I almost forgot that I have an A there that I can mutate. So first let's mutate the A, and just remember that it looks cool at 2. Somebody said, how come the Discord link is expired? Now, I haven't been on the Discord in a while. I need to check in on there. I haven't been using technology or social media much recently. So I'll need to check in on that. I still need to get back more into interacting with the community like I was doing at some point, and I want to do again in the future. I've just gone through a quite introverted phase, and honestly a kind of difficult past few months, but things are okay, and I will explain some of the details in the grade -1 or grade -2 finale, which will be coming not that long. We're near the end of grade -2, meaning next is grade -3, and the grade -2 finale will explain a bit of some behind the scenes. And with that, the main combo class channel with my main episodes will have 3 more episodes, because I wanted to make 36 main episodes again in grade -2 like grade -1. So we're gonna have 3 more episodes. The next one I've already filmed, and it's sort of a nature-ish one, but it's about a mathematical concept within nature, so it's a mix of math and nature. Then there will be 1 more main normal episode, and then our finale that's sort of like a more of a behind-the-scenes documentary about the grade. Then we will have a very short pause, just a couple week pause, and then we'll be on for grade -3. And grade -3 will be very exciting because 3 is a really cool number, and so -3 should get some credit too. And we'll explore a lot of 3-related concepts next grade, including a lot of triangle-related episodes, as well as 3-even numbers and other cool aspects of 3s. Speaking of which, let's set this A to 3. Now, that makes them wavy. It connected all the islands, but maybe they were already wavy. I guess they were wavy as islands, and now they're connected. So if we go over here, it kind of gets more boring, kind of becomes more linear. If we go this way, we get a little more wiggle room. Oh, and it flips. I almost didn't need to flip the inequality because we can make them flip on their own. Now here's if we want small islands and more water between them, and here's if we want some pretty big islands that you could like almost hop between. Now, do the islands end up touching? I don't think so. I guess, yeah, they stay separate. They just get closer and closer, but they also get smaller and smaller. And this one looks like a banana. Now, what I wanted to try to skew this a bit is multiplying this by a separate variable at different points. And first I'm just going to try multiplying one of these on the outside by some b. And this, if we set b larger than 1, well, normally would stretch it, but these bars are staying there. Those bars are just wanting to be there. So even if I square it, yeah, those bars just really want to be there. So what if we put our b inside? Okay, challenge. Get rid of these in-between bars and keep our islands. I don't know if it's possible. But we're just going to try some more experiments for the time being. And for the time being, but b is gone. For the time a-ing, more like. Oh, this one's kind of neat. You get these like crab-like fellas. Then they turn into this more soft-looking thing. And then they start splitting. They start separating more. And yeah, you get more and more slices that are separate. Like this one has 2 separate, and then it has the rest are like thorns or like leaves. But these 2 separated. Now I bet if I go far enough, yeah, there's 3 separate on this one. This is a pretty small little separate slice that fell. And if we went way further, like down here, there's going to be more separate slices probably. Yeah, this one has like 5 or so separate slices. Now, what else is going on just with our different A's? Okay, where am I? Okay, here am I. What else is going on just with our different A's? We can go that way. Yeah. So, that's pretty neat. And what we'll try, that was substituting a tan in the middle. First, I guess I might as well try throwing in a tan on there too as a substitution. That's all right. Now, what we'll do here, let's keep these there and try a few different combinations on the outside. So that sort of flipped it, and we get these, like coming in these bars, this pattern we've created. So let's try something new. Now we multiplied them together, and now they made this whole weird, like, crazy version of a checkerboard. This would be a cool board game if this was somehow, like, the way the squares worked. And that's at that value. Oh, this one's neat. I like this one. Let's flip this, because then we'll see, like, these things on their own. Yeah, that's pretty neat. These weird guys. And we can grow them and stretch them a bit, merge them, shrink them a bit. Okay, so now that we've gotten this whole weird web, I'm going to go back to sort of one of these weird board game looking ones. This one has these lines I want to get. That's at 0, is kind of cool, but we're going to go a little past 0. We'll put it at 0.1. Do you even let me do 0.1? Yeah, A is 0.1. So now they're almost touching here, but not quite. Now we can try some different combinations. Here's this one. we get this sort of shape pretty often. And we could try that one, and we could try substituting some over here. And some of them get kind of boring, like these ones multiplied into these lines. Sometimes, since these can be defined in terms of each other, like you can define these a lot of ways. Here's exponential definitions, here's complex trig definitions, but a lot of them are related to each other the same way that the 6 main trig ones can be phrased sometimes as a fraction of this over this equals this. And sometimes you like cancel out, and here it's like something canceled out the interestingness. So that we don't want cosine or hyperbolic cosine and hyperbolic cotangent multiplied in this way, I guess. Or is that the problem? Yeah, that's the problem. Is those things, when they multiply together, they cancel out the coolness. See, there's the coolness again. Coolness back. Now, let's give these a little more room, and let's see what else we can add here. What I want to try to make this extra colorful and have more going on is, while we change our A, let's have 2 graphs going that will be slightly different. So, first, what'll our main difference be? I suppose our main difference will be that one will add these 2 sides and one will multiply them. And I'll change them relatively the same as we go through these different patterns. And now we get this extra sort of colorful combo. And although it may seem random at many points, there are points where they definitely line up. Like, do you see right here that this line goes straight from red to green? We can see the bits that are red and green. They're the darker green shade is the red and green. Both are true there. And so right here, there's like a line between where red's true and green's true. And we can see that there's points where they meet, sort of. And when we have similar types of things going on, even when bits of them are random, other bits of them line up and grow together and even approach each other in interesting ways. This is kind of neat. I like this one. You get these like ribbons. It's like a tie of sorts. So fiddling around with this is always good. We'll keep 2 for now. Maybe I'll add a 3rd in a minute. Now, I am excited to move onto our next grade -3 soon. Grade -2, I decided in advance some things, like I wanted it to be 36 episodes. I wanted to, as an experiment, not cut my hair since the grade -1 finale until the grade -2 finale. So that's why we're looking extra chaotic. And as usual, I usually, don't get a new desk or a new lab coat until the new grade hits anyways, too. So luckily, it'll be almost time to cut my hair and get a new lab coat that doesn't have a big burnt hole in it and stuff like that. Of course, we'll keep the lab coat. I still have the grade -1 one somewhere, although it's quite burnt after the grade -1 finale. But I'm excited to move forward onto our next phase, and who knows what will happen in grade -3 apart from a lot of triangles. That's the only guarantee, is we'll learn a lot about triangles. You'll see what else happens. There'll probably also be other similarities with these grades, but there may be new experiments as well. I like these mini islands. So, like I said, there's going to be 3 more episodes, and the amount of time that will last approximately, which there'll also be a lot of bonus content on this channel along with those, will be about a month, maybe 2 months. So I would say that the grade -3 should be starting, and it will be a whole new step in evolution for Combo Class. You'll see some of the tricks I'll have up my sleeve. will be starting around the beginning of October to maybe sometime in September. And that will be a whole new fun arc. For now, I need to run inside for a quick second to grab some water, and I'll be back to fiddle around with more graphs. For now, what I'm going to do is try and set this animation really slow so that I can put the animation on for a moment. I'll be back soon and we can chat some more. Leave any questions if any of you have any questions or random thoughts. And then I'll be back for another 20-30 minutes or so of creating cool shapes and chatting about some random topics. To anyone who leaves early, hopefully you are leaving early to make sure you have seen my new combo class episode. But in any case, I love you all, and hopefully this animation works to some degree. All right, folks, I am back, and let's pause this animation. Was the animation even changing anything? Hopefully it was working. And anyway, we're going to fiddle around with this more and chat a little more. I realized it is right now the Olympics, which a lot of people enjoy watching, so Glad all of my people here care more about this than that at the moment. And personally, I have never been much of a sports guy. Um, I've always thought that sports should be more interesting and around more weird records. So, if anything, the Olympics are closer to what would interest me because it's like, okay, who's the best in this strange category? Sort of like a world record of sorts is more interesting than resetting the exact same team record with 1.01% faster than a lot of people have seen a million times before. And so, the Olympics would be closer to the type of sport I would find interesting, but I think they could make it crazier. I think that sports should have, like, you got to spin a giant wheel before you do the sport. Like for team sports, let's say for like basketball or something, you should have to spin a giant wheel beforehand, and it should have weird like penalties that you have to do as a sort of handicap of sorts. Like if you had to, one of them would be you have to be on ice. That one would affect both teams. You could have one that was your team has to be handcuffed in pairs. One of them would be that you have to be blindfolded, and that would make the sport so much more interesting. But anyway, who knows? Maybe someday we'll make the combo sports show the way shows should be, where it would be very unpredictable. You shouldn't know what you're going to see before you watch the sport. And anyways, playing sports I will never advocate against because that is good for your body. So playing sports, unless you are overly obsessed with it, is good for you. Watching sports, I'm not one of the people who that hits the funny bone of or whatever. And so, I like watching YouTube. That's why I like making YouTube. And like I said earlier, recently what I've been watching is a lot of David Attenborough nature documentaries because those things are crazy. Like, I always loved the ones called Planet Earth. That's a great series. Let's switch which one's where. Let's put the hyperbolics on the inside and the non-hyperbolics on the outside. Now, I was watching another one that's very similar, but only about undersea recently. It was called Blue Planet 2, and they didn't have Blue Planet 1 on the service, so hopefully I didn't miss too much of the lore that was important for it. But, oh my god, those deep sea creatures are absolutely insane. There's some scenes that, I had to show my friends. I was like, you have to watch this scene from a nature documentary. It's just, that weird. I was like, I already watched it yesterday, but I'll see it again. Is that crazy? So, hopefully someday we'll get to explore the jungles more on some field trips. I don't know if I'm a big submarine guy, so we'll see if we ever do the deep sea creatures. However, you can see certain things that are almost as cool as the deep sea ones, and relatives of some of them, in tide pools. So maybe we will do a tide pool field trip at some point. Now, I do want to go on more field trips where I just go camping somewhere and film an episode or two there, because I love camping in a tent somewhere. It's cheap. You get down and dirty in nature. It's great. But right now, for the grade -2 finale, I'm planning a miniature camping trip that I'll do at some point in the next few weeks, which is not really a camping somewhere else field trip. It is just a fun little experiment I liked to do in the last finale and wanted to do again, which is, since the combo classroom is already somewhat dismantled and in a state of decay, because it's near the end of the grade, and that's how things work in cycles, and it will get even more so that way, because I'm gonna, when the grade's done, throw away a lot of the old rotten stuff and fully shattered stuff and replace it with some new stuff, and the cycle will continue. So while the classroom's emptier, It's fun to camp in the classroom itself. Just set up a tent here when there's room, which is sort of right now because you may notice we're not at a desk. I don't know if you could tell, but the desk is back there. That's the desk right down there. So yeah, we're at the point of the grade where the classroom is sort of like a clearing, and so a good time to put a tent there. Now these are looking pretty cool. Look at this part right here where these go back and forth. These ones are like spiky, and then these ones are all wiggly and wavy, and it's almost like that's the coolest corner. It does different stuff in each corner. These are like not quite as interesting because they're just the green stuff. This one is both, but it's like more predictable. But this side does trippy stuff. So the reason why it's not fully symmetrical all of these ways is because I have different stuff going on for the X's and Y's. I think it'll look a lot more symmetrical even if I have this one added and this one multiplied, if I make these the same, because with each X and Y pair, they're commutative. So let's see if it symmetricalizes it a bit if we make these the same as each other. And this one goes to this. Well, I'll match that there. All right, now they're the same except that one adds and that one multiplies. And yeah, now it's a lot more symmetrical in these axes, but it's also a lot more boring. Oh, speaking of symmetry, there's this fun tool that I found. I'll show that in next stream. That was just like a cool symmetry doodler of different types of symmetry. I'll do that in the next stream. So these were some fun combinations, but now it's time to move a little further. And the way we're going to move a little further, first I'll just delete one of these. We can add an alternate clone of it later. And we're going to add some more crazy stuff. First, what we're going to try is some exponents, and we're going to try the exponents on the ones where we separated and multiplied them like that. Now here we get sort of a normal looking type of curve. It's actually a little less crazy than it was before. Maybe the tan is blotting too much stuff out. Those can make it pretty... Yeah, the tan was blotting too much stuff out. Those can dominate it too much. The tangents, and I guess the hyperbolic tangents too, sort of like just dominate it all and make it go a certain direction sometimes. Look at what happened when I switched that. This is a whole little world. This is a planet. Or like an anti-planet. Well, let's switch the inequality and make it a planet. Wait, what happened? Oh no, that was the same way. This way. Yeah, look. It's like Earth in space with different continents on it. That's wild. And then it just goes like really dense down here. It looks all like dark and fuzzy at a certain point because they're just like can't do all the detail. And then it looks dark at a certain scale because it's sort of just getting closer and closer down this weird stairway to somewhere. Or is it going somewhere? Depends how you define somewhere. Now, this is our planet. Somebody said to add a factorial somewhere. Now, factorials are sort of weird because they are actually using, I believe, I haven't looked this up, but from what I could tell, from what I could make an educated guess on, the factorials here, since you have to extrapolate data between the factorial function, it's a weird thing I haven't made an episode about yet, but to get the info between the factorials, you basically want to use this thing called the gamma function, but the gamma function is offset from the factorials by 1, which makes it just trippy to describe and look at because it's just off by 1 from what you expect. But there's another one called the pi function, not actually related to the number pi, just the Greek symbol is used for various stuff in math. And, you know, there's only so many Greek letters. And the pi function is like sort of like a non-offset one. So I think they might be using the pi function or like the gamma function with plus or minus 1. But I'm not sure, but we'll try it. Okay, this might make everything go way too crazy, but we're just going to try it. There's factorial. Okay, I put it outside the stuff, which is a little easier on it at first. And yep, we get pretty wacky. I will at some point make an episode about the gamma function, which explains like, well, what are you talking about when you say this is 0.5 factorial or stuff like that? I mean, we're not saying it's 0.5 factorial, we're saying with this equation, but if you were to look at just y equals x factorial, like, what are we talking about here? You know, why did the negatives do that? And what does it mean that, like, 2.5 factorial is that? You know, this is an approximation of it, though. But we'll look at that someday. But, okay, we'll put the factorial in for now. And we'll try even putting it somewhere on the inside. Whoa! It killed all the outside. This is awesome. Okay, good suggestion. You know how I said I liked islands? Well, look, we have made a self-contained universe. It's like this crazy version of an island. So this little self-contained universe has our like ocean with some islands, or you could imagine it the other way around where there's some land and some lakes. And then you get your crazy dense zone where it gets denser and denser and denser toward infinity. And normally when they go denser toward infinity, they keep going toward infinity. But this one gets like tight enough with its progression that it's like a convergent series in a way, or I mean reminiscent of one. And it like stops. That is pretty cool. Okay. I'm going to have to remember that one. There's our equation for that. And now let's make some friends for it, like when we had plus there instead. Plus there still keeps it in that zone. So it looks like, okay, I'm just going to mess with this side and see if we still just get contained in a circle. So here we'll change this guy. Yeah, we're in a circle. This is so crazy. All of this is just like automatically in a circle. This is so wacky. Okay. So now we have all these different planets we could create just within one realm. Now, what if we want to change this circle a little bit? What if I like multiply it by something? Will that even change it? No, it still wants to be in the circle. Okay, so what if I multiply the whole thing by a variable over here? It really wants to be in the circle. That's crazy. Okay. So here we can even just make different islands just with our slider. These are like little dusty universes. Like that's like how planets form, you know? This is the exact version of how a planet forms. Now, well, obviously not, but it's kind of very reminiscent. And then this is what will happen to the planet in the year 2027. No, I'm kidding. Okay, let's fiddle around with these a little more. Let's put the friends together. And, yeah, what happens when they're both there? All right. I just need to experiment with this a little more. What happens if I move... Okay, we're going to be doing too much, folks. We're going to put another one. Okay, I put another factorial, and it made it into this weird, almost rectangular shape. Except, like, not only is it more squircle-like, but or rectangle-like, but it also has this little dip in there. It goes, like, a little less there than there. It's weird. So, yeah, now we're stuck here. It's once again, we're stuck in the shape that we've created. This is crazy, but we changed the shape. We changed it from a circle, but now we're stuck in a new shape of universe. Now, someday I am going to make a main combo class episode that explains a little more about what goes on when stuff like this is happening. Probably not with, like, this equation, but like what happens with simpler versions of this, what's actually happening. And when I make that, I'm going to have to go through all the streams where I have done graphs and collect the best ones, because every time we do this, I find something I've never seen on a graph before. Somebody said it's like a YouTube play button. It is kind of like that. And thanks to all of you folks, I have one of those. And we're almost halfway to the other one, which is actually for my main channel, ironically. But we're almost halfway to that one also. That'll be pretty crazy when we have 2 of them. Then maybe I'll feel fine with like doing a weird science experiment on one of them. Or at least leaving it out in the classroom. I don't even like leaving the one I have out in the classroom, because that's like an honor to me. But when I have 2, maybe I'll leave one out in the classroom and see, you know, if a bird carries it away, we have the other one. We'll see. That is sort of like a special honor to me, because I've always loved YouTube, and I kind of can't believe that within about 2 years we got, well, it was less than 2 years that I got that, but within about 2 years so far now, that we already have that and more. Okay, we didn't really change the shape, I don't think, but we changed what's in there in a pretty crazy way. It looks like a spider web almost. I might as well take B off. That might be confusing some viewers. We don't even have B in there. Look at that. Here it's almost like an eye shape. And then look at these weird spirals that come out of it. And then if you go over here, it's like doing the spirals, but like way faster. This one looks like lightning bolts shooting out. So this one's pretty cool. And it's like, if you were zoomed in here, you might think, oh, that just goes upward and upward. Nope, comes back around. Sometimes you gotta zoom out pretty far to be sure there's not anything hiding back there. But yeah, we're now stuck in the play button shape. Somebody says they didn't know about this channel for a while. They started with the combo class channel. Well, the combo class channel did come first. Some of the content for this channel was filmed at the same time I was filming the first few combo class episodes. But like some of the shorts I was filming at the same time, but I didn't actually make this channel till after I had posted some of the combo classes already. And shout out the viewers there, but on that channel, like, I don't have any shorts on there, and those really get like a vast number of subscribers quicker because it shows it to random screens. And so the combo class channel may always have less than this one if I keep posting the shorts on here, which I'm doing at least for now. But that's okay. The combo class channel, the extra diehard fans are on both, and different viewers like different things. But the combo class channel is like my TV show, and this is sort of like my playground. Okay, so these are cool. Now we're going to change it a bit. What if I took out this one and only had it in there? Okay, now we're not stuck in the same shape. So this actually changed something here. Oh no, wait. This guy got changed from there. Tan sine. This one was sine tan. Tan hyperbolic sine. I'm trying to match them a bit so they go on similar paths. Now, okay, we've broken free from the circle and the play button, even though we have the factorial in there. Now we have this interesting thing going on where, like, these ones form like this mix of like a mouth and an eye. And now it's bigger and bigger things that are cool. They sort of spiral outward in those weird gaps. Starting from this extra big one, then it goes to these small ones, and then bigger. Now what happens when we adjust this? So now our shape's changing more again. This is, while I do like our singular island, it is also nice to be broken free from the circle and play button shape. Look at this. This is wild. This is absolutely insane. Oh, man. These should be printed for, like, wallpapers and shirts and stuff. Like, I mean, not like computer wallpaper, although that would work too, but, like, I mean, like, an actual wall of a house should be decorated like one of these. You should find one where there's a spot that looks like a door and paint a whole wall like that with the door in the spot that looks like the door. Look, these teeth are chomping when we go this way. It's like a mouth. You want to see the mouth chomp? Alright, well, here the mouth's chomping. Chomp. Oh, it chomps too far. It's hard to make it chomp the right amount. Okay. Oh, and if we go all the way over here, we have almost nothing. These look like tiny dots, but if we zoom in... I was going to say if we zoom in, they're more than dots, but maybe we're not even able to see it. Maybe they're like such... Maybe they are just tiny, infinitely small specks. Who knows? Now, this is like the most boring state when we're at hypernegative. Coming back, we get some of our weirder combos again. Now, we're going to probably live stream up until it's been 1 hour. So if anyone has any remaining thoughts or questions, now is the time before I get distracted with any concluding thoughts. In any case, a lot of fun things are coming in the combo. Oh wait, I put it in the wrong spot. A lot of fun things are coming in the combo realm. For now, we're going to crank this up to the maximum to see how much we can do before it completely glitches out. I have now added a second variable. Now when we have 2 variables going, one of the crazy things to do is if we set them at different amounts, like that one from -10 to 10 and this one just from 0 to 10, then, or let's say it's -5 to 10, and then we put them on animation, then they're going to have like a nearly infinite. In this case, they'll re-overlap at a certain point because of how multiples in common work here with the -5 to 10 and -10 to 10. But it'll take a while before they re-overlap and hit the same point. They're going to at first be hitting all these different paths and patterns as they come back at different times. Like to make it even more so, let's go like -3 to 10. And now they're going to, you know, by the time that one slides up and slides back, they're going to be going at different rates and keep crossing each other in different combinations. Now, with all this going on here, this is probably going to glitch really badly. But let's see if we can make it work at all. Oh my god, already this is so beautiful and weird. Look at this. Look at this. This one goes down like a snake. It like they're going down but also at an angle. Oh my god. These ones it always blows my mind when I do this, and these aren't things I planned in advance. The only thing I planned in advance for the stream was we are going to put hyperbolic trig functions in weird equations. And you just always find the coolest stuff. Now, let's see if this is going to work. First, we're changing B in our animator. Now, we're going to see if I can change A as well. So, they're going in a somewhat glitchy fashion, but we can see the shapes changing. So, it's working to a good enough degree. And let's see what these mutate into. And like I noted, it's not just going to be when one of the sliders goes back and forth, that's our pattern. They're going to be at different combinations of the 2 variables for a long time because they're at different amounts that they're looping back and forth between. Now, they're going really slow, so not as much interesting stuff is happening in this realm. So for each of them, let's find their like really interesting realm where they change. For B changes things the most in like this zone. So we're going to put it from like -3 to 3. And then A goes craziest like down here. We're going to put that from like -7 to 5. And now we're going to maybe get a more condensed version of them going through interesting states. So, some of the simplest ones, maybe if I ever like make combo class like shirts or anything, I'll put some of the simplest, craziest graphs I've discovered on them. Because these, like I said, I want to paint my wall with these types of shapes someday. So they're not at the most interesting state right now, but as we stay tuned, they're going to evolve into crazier and crazier things. And I'm going to zoom into a slightly closer spot right here where we can see it happening. There we go. Whoa, whoa, whoa. Now, since I said we're going to go as crazy as we can to break it at the end of the stream, we're going to add a third color. And the third color is going to be similar so that we can have it sort of in sync with the other ones. And so, you know, for now, let's just try, instead of plus or times, let's just try minus and see if that creates anything important on its own. It's sort of blotting out the other ones right now, but let's see if that continues to be the case. Man, this really looks like a mouth. Okay, so, in not too long, I'll be wrapping up tonight's stream to work on some things, one of which is I didn't want to make another whole stream about this because I already have done some stream topics about this in some of the past recent ones, but I have been working a lot on designing games, and designing in particular one game based around what I nickname numberations, which are different cards that will be essentially a function that turns one number into another function, but typically in the form, not all the cards are, some of them are, you do this to the number, and it's sort of some sort of function that turns into another number. But most of them are in the form of an operation and then a number, such as ×2 or to the power of 2 or -1 or something like that. And I've been designing the mix of cards that I want to include in a starter deck, which is tricky because, you know, you want to include all of them. You want ×7s, you want to the powers of 3s, you want plus 50s or whatever. You want all sorts of stuff you can't include all of, and so it was really hard to narrow it down to about 22 different numberations that will be in the deck with different amounts of them each. I might narrow it down a little more to 18 or 20 of them, but right now I'm at 22, and I'm actually working on graphic designing the cards themselves as well, and working on how I'm going to write the rule book to it, how the simplest way to describe the rules fully mathematically but still making sense to somebody who doesn't know as much math terms. And so how to describe the rules as concisely as possible, and kind of like I had to pick which cards I want to include, I'm going to have to whittle down all the things I'm going to want to include in whatever little booklet I include with the game that says which variations you can play. Because I've come up with so many different variations you could do that I can't even include all those in the booklet. So I'm figuring out the best stuff that makes sense for a starter game. And like I've noted in the past, some of my goals for this are, for one, I want it to follow what's known as Zermelo's theorem. Watch my episode about Connect 4 if you don't know what that is. For two, I want it to be a game that does not require, well, let's see, I guess not requiring luck is sort of implied in Zermelo's theorem, but like some games in that, I want to be something that is not easily solvable and could have a dense amount of strategy without having very complicated rules. I don't want to have, a mountain of rules for the complexity. For example, I think even chess, while it is vastly complicated, could have been simpler and still had enough complexity. And I mean, simpler not in terms of how much strategy there is. The goal would be to have as much of that as possible, but simpler in terms of like how many different pieces with different rules you need, or traits like that. And other traits are that I want it to be fun to play, like at a party, but that also you could mathematically analyze it and come up with cool patterns about number theory from it. And another is that I wanted it to have many variations in one game. And the way that works, which I'll explain more about another day, is sort of that although you can just shuffle the cards, or you can lay them out in a specific prearranged map, and I'll recommend certain maps, you can also design a map out of the cards that is sort of like the setup for the game. And one of the main ways to play will be for one player to design a map out of the cards and for the other player to pick if they go first or second. But I also wanted it to be something you could shuffle and play, or something that could have, specific recommended maps for. Somebody said they're still trying to prove prime flip. That's awesome. If you're referring to one of the things I made a bonus video about a while ago, that's really cool. And I'm going to someday make a full episode on the Combo Class channel about it when I revisit that myself and look deeper into if I can prove any more about it. But for now, that one's sitting in the vault, but there are many ideas like that that I'm excited to show the world. One of the main ideas that I personally discovered that I want to make an episode about hinges on a few other episodes first that need to come in grade -3, which are triangle related, because I discovered this sort of pattern that one of the simpler examples of relates to this shape called Sierpinski's triangle, and to explain that I need to explain Pascal's triangle because they're interconnected. So we may have a triangle trilogy in grade -3. That was a fun thought I had. What about a triangle trilogy? Not only is it alliterative, but it's alliterative for a reason. They both have the tri root because they are both 3 related. And I have more than 3 episodes of triangles brainstormed, so even fitting it down to a trilogy will be a challenge. Maybe it'll end up like a Douglas Adams style trilogy. We'll see. In any case, there will be triangles in grade -3, and there will be other 3 related things. For now, 3 more episodes of grade -2. And make sure that you have caught the last one last time. I'll remind this, new episode came out about a day ago. Also on this channel, a few new shorts came out in the past week. I'll have more of those soon as well. And that's about all for today's stream. I think these shapes that we found are pretty cool, and these are the graphs that we were using. Here, I'll just stretch this so you can see them for a second. And now we can revisit these with more variations in the future. If anyone plays around with these on their own, leave a comment on this video. You can leave comments when they post as videos after the live stream too. If you find any other cool settings that create particularly cool islands or things that look like other things or fractally patterns or etc. And somebody mentioned Sierpinski's gasket, which is another fractally shape. Somebody also mentioned the Game of Life, which is a brilliant game by John Conway, which will have an episode someday. Very beautiful. In fact, that's one of the things that I want to make an episode about, and I'm basically ready to. I know what I would put in the episode about it, but I want to maybe work with a programmer to animate our own version of the Game of Life instead of relying on another online resource. And I have not been good recently about doing things like responding to emails from people or checking in on the combo community much, but I'll explain more about what's been going on in my life as time progresses, some of it in the grade -2 finale, and other things maybe just in my memoirs someday. For now, hopefully you will enjoy the next combo class episode, which will be out in about a week, maybe even less. It's sort of a bonusy one because it's sort of like a nature break in a way, but it is math oriented as well. It's about a mathematical pattern that happened in nature this year. And hope you enjoy the other shorts and stuff that'll be coming soon too. And I hope you all have a wonderful day. I'm going to, or night, probably for many of you. For me, it is night. It is now 10:40 p.m., so we are going to wrap up. And I love all of you combo lords. I'll catch you again in the next stream. And until then, make sure to experiment with interesting things in the world, like looking at some cool plants, petting some cool soft animals, and designing some weird graphs, or, you know, doing whatever personal investigations you can find interesting. And I'll be back with some of my own personal